Well, hello there, YouTube. Welcome to my channel, Tech Talks with J Square. I am your host, Jetta Jones. If you are new to my channel, make sure you subscribe, hit the notification bell, like this video, and leave me a comment after watching. Well, today we are going to do a whiteboard session on direct attached storage. We're still continuing our series on enterprise storage solutions. And don't worry, we are going to talk about so many other different exciting topics, but today I want to talk about direct attached storage, or DAS for short, because it's only fair. You know, I've talked about SANs on this channel many times. We've talked about object storage. We're also going to cover NAS storage, and these are some of the most common enterprise storage solutions available today for modern organizations. So I want to start off by defining what is direct attached storage, or DAS for short. Well, it is a storage architecture where the storage system, a disk array, a JBOD, or even internal disk is directly connected to a server without going through a network, unlike when we have a NAS or a SAN. Let's further start off by diagramming what is direct attached storage and what it looks like. So there are also three options. So we're going to talk about all three. Number one, these are three different ways organizations can implement direct attached storage. So two, have a JBOD. And then number three, which is my favorite, an enterprise disk array. And I'm going to put enterprise here. Okay, so let's diagram what option number one is. And you're very familiar with this, and servers are still using all of these implementations, even in a NAS. So this is not unusual. It's all about where the data is being stored, because data is everything, okay? So number one, internal disk. So we have a server here, and this server is running an operating system, could be Windows Server, Unix, Linux, Sun Solaris, it does not matter. It also has some type of business application running locally, could be SQL, Oracle, VMware virtualization, or some type of homegrown application that was built specifically for the organization. So we have internal disk of this server, and in this scenario, you have an operating system installed on the server, you have an application installed, and the data is also installed locally. Well, this is what the storage architecture mainly looked like when I first started in the industry. Now, there are still some use cases, and this is considered a single tenant server, okay? So what do I mean by single tenant? This means this server is running an operating system, it's running an application, only one application, and it also has data stored locally. Well, you know, even though we have, you know, some very more robust solutions like enterprise disk arrays, there are still use cases for single tenant servers, especially if the application is performance intensive and it wants to take advantage of all of the hardware resources such as the CPU and the RAM. So single tenant direct attached storage is still very popular, okay, in certain use cases. So number one, utilizing the internal disk, that's considered direct attached storage. Number two, a JBOD, just a bunch of disks. In this scenario, we also have an operating system installed, some type of server operating system. We still have the application, the business application installed locally. But in this scenario, we attach an external JBOD. And this could be connected generally through a SAS cable. And this is just a bunch of disks. And think about this scenario. You know, you guys all have desktops, laptops, and once your internal disk to whatever your personal computer you have run out of storage capacity, well, you can go run out to your local Best Buy, purchase an external drive connected through your USB port or your Thunderbolt port on your computer, and you instantly have more storage capacity. Well, this is what a JBOD is. It gives this server, once it runs out of space, because remember, servers only have limited scalability. If you watch some of my previous videos on SANs, limited scalability. So once you max out on storage, once you max out on performance, well, you have to purchase a new server, or you could do a JBOD, but you don't get the sophistication with the JBOD than you would with an external storage array. So number 2, JBOD, we have number 1, internal disk, and number 3, which of course is my favorite because it is the most sophisticated. You're going to get so many great capabilities that is more suited for enterprise level data, because data is everything. You're going to hear me say this so many times on this channel. So let's look at option number 3, an enterprise disk array, which is by far my favorite because this is one of the most sophisticated storage solutions that is going to give an organization so many capabilities and data protection, storage optimization for their data that they will not get in option 2 and they will not get in option 1. So let's look at the storage architecture. We have a server. Of course, this server has internal disk, has an operating system. It has some type of enterprise application similar to what we've talked about before, or some homegrown in-house software development application specifically for the business. And the external device is an enterprise disk array. It's a chassis just like a JBOD. It has multiple hard drives, single hard drives in this chassis. And it pulls all these different hard drives into one single unit or one single pool of storage. And this disk array can house traditional hard drives, traditional spinning disks, where you're going to get more storage capacity at a lower cost, but you're not going to get that good of a performance. So it's really good for infrequently accessed data, warm data, archive data, okay, that does not need that fast performance. It could be SSDs, solid state drives. Those are very common, high performance, low latency drives, really good for mission critical workloads. So this chassis can have all HDDs, all SSDs, or it could be a hybrid, a combination of both. And you can use tiering, and I'm going to talk about that in a second. So let's list out some of the capabilities of this disk array. So there is redundancy, scalability. We're going to talk about all of these, okay? We have storage optimization, data protection. Okay, so we're going to briefly cover all of these, okay? So let's look at redundancy. So this disk array has a lot of redundancy built into it. First, it has 2 controllers, dual controllers, and of course these controllers have ports. So, and remember we said a DAS does not go through a network, it's still direct connect storage. And this disk array is the same disk array that you would use in a storage area network. The only difference is with the SAN, the devices are connected to a fiber channel switch. In a DAS environment, the server directly connects to the back of the storage device. And in this case, it's an enterprise disk array. So you have one cable there and one connection there. So you have 2 connections to both of these controllers. Again, this disk array is highly available. It has redundancy built into it. It has 2 controllers, and the controller handles the I/O processing and data management. It's also there for redundancy. So it makes sure this server has 2 separate paths to get to the data that's stored on these drives. Okay, so if one path goes down, a port goes down on the controller, or the whole controller goes down, there is another path to get to the storage. So really good redundancy. This disk array also has redundant fans and cooling, redundant power supply. So just about all the components that commonly fail on IT equipment is redundant. And then there's scalability. So remember I said there are multiple hard drives, and it pools all these hard drives to create a single shared pool of storage. Okay, so that's where you're going to get that scalability there. And also, you know, an organization can start off with, it doesn't have to fill all of these slots, right? So maybe they start off with 5 drives, and these disk arrays can hold petabytes worth of data. So that's where you're going to get that scalability you're not going to get with these other solutions. So they can start off with half of the slots filled and then upgrade later, or they can also add an expansion shelf. So the expansion shelves have additional hard drives, and also it can also help with performance. So that's where you're going to get that scalability, petabytes worth of space to store data. Once you max out here, you can add another, you know, expansion shelf. You're going to get more performance as well as more storage capacity. And I also want to talk about this scenario. You can also connect multiple servers. Remember, even in a SAN, multiple servers have access to a shared pool of storage resources. Same here. The only difference, like I said, SAN uses fiber channel switches. These are direct connect, and you don't have as much capacity to connect nodes to this disk array, but you certainly can connect more than one. So again, 2 connections. So now you got multiple servers that are using this shared pool of storage, okay? So you're going to get great scalability there. And then you have storage optimization. Storage optimization includes deduplication. You know, the disk array has software and capabilities and intelligence built into it. If there's duplicate data out there, it will get rid of duplicate data. It has compression 2-to-1 or 3-to-1. It compresses the data. So for example, if you have 150 terabytes worth of data, once it's compressed, now this is just a scenario, hypothetically speaking, you will only be using 50 terabytes worth of space if you're doing something like 3-to-1. And then there's tiering. Okay, so what tiering does, tiering automatically moves your data to the right type of hard drive. So remember I said in this chassis, let's say you have HDDs and SSDs. So you want your less mission critical or less frequently accessed data on HDDs and your high performance frequently accessed data on SSDs. Well, tiering can move data and place data on the most appropriate type of drive. So for example, maybe there's data sitting out there on a SSDs because they're more expensive, because they're high performing, and it has not been accessed in 2 years. Well, tiering can automatically move that data from SSDs to HDDs, because it's almost impossible for a storage admin to do this manually, to figure out, well, oh, this data has been accessed in 2 or 3 years, or this data is now frequently accessed. So tiering is a really good option. And then data protection is huge. There's so many capabilities built into this disk array. It also, you know, runs a software layer, and that software layer gives it so many capabilities, from storage, virtualization, data replication. And what data replication does, this is really good for disaster recovery. You can have 2 disk arrays, right? One at site A and one at site B, okay? So you have 2, and this is your primary, and let's say this is a disaster recovery site. Well, you can replicate data between those two sites. So this is your primary site. You can replicate your mission critical workload to your secondary site in case there's a natural disaster, a major hardware failure, a huge cyber attack. You will have a copy of your data at your DR site. So this is replication. Talked about replication there. And let's talk about snapshots. I love snapshots because snapshots have so many use cases. So snapshots is just a point in time copy of a previous system state. Think about a camera. You take a picture, it's a point in time of a memory. So snapshots take a picture of the data, and you can set that schedule up every hour, maybe every couple hours, and it stores those snapshots on the disk array. So let's say this is the disk array. Okay, these are the snapshots. That's a copy, that's the copies. You know, again, every hour, every 2 hours, that's up to the administrator. And so this can be used to, you know, for that fast recovery. So let's say a user deleted a file, you know, maybe 2 days ago, maybe it could be their Excel file. So that user doesn't have to call the help desk. You know, they can go look at a previous snapshot and say, oh, you know, here's a good file. Here's the good file that I need to restore. They can restore it back to their local computer. And snapshots are really good for that self-service. You know, a lot of disk array vendors are now incorporating immutable backup snapshots, you know, using it for that use case. So these are immutable. They can't be deleted, altered, or changed. And some vendors offer, you know, those snapshots to be logically air-gapped. So what an air-gap is, the backup copy is on a different network than the primary source. And there's an air gap. So if you have a cyber attack, more than likely the hackers are going to target the primary network or the data on the primary network. And if your copy is on another network, hackers can't get to that, okay? So that's an air gap. But vendors now are creating immutable backups and logically air gap right on the local disk array. And what this does, it will allow organizations, if they have a cyber attack, to recover very, very fast, because the average recovery time from a ransomware attack is 23 to 24 days. And I'm going to do a lecture in the future about cyber resiliency and cyber security. But I wanted to just touch on some of the use cases for snapshots. So we have snapshots, replication. Of course, you know, you can do backups, and you're going to get that really good data protection. And also, I got to note, these drives are hot swappable. So hot swappable drives. So if a hard drive goes bad, pull out the bad one, put in a new one, no downtime, no impact to performance, no data loss. And also, RAID protection. Depending on what RAID level you have set up, you can lose one or multiple drives. So a hard drive can go bad, 2 hard drives can go bad, and it will not cause an outage, data loss, or data unavailable. So I hope you enjoyed this mini whiteboard on direct attached storage. You know, again, we have internal disks, we have JBOD, and then we have enterprise disk array, which is my favorite, and this is the one that I recommend. And also, I want to note, I forgot to mention this, the connection here is fiber channel. Now, you can use SAS and other technology, but to get the best performance, I always recommend fiber channel. So you have a fiber channel cable going from the server to the disk array, and here, you know, more likely is a SAS cable. And then, of course, this is internal disk to the server. So drop me a comment. Let me know what you thought about this whiteboard. Let me know if you have any questions. Does your organization use direct attached storage? Do they use a SAN? Do they use a NAS? Are they using object storage? Or are they using a combination? Because a lot of these solutions, these storage solutions, are complementary as opposed to competing. Well, I enjoyed you guys, and I look forward to seeing you on the next video. Take care, friends.